Kubernetes and GKE Part 43. This episode has 20 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. How do you write production quality Python scripts? Here's a strong way to approach it. Use functions, type hints where helpful, argument parsing, clear logging, config files or environment variables, tests, and robust exception handling. Avoid hard-coded credentials and magic values. Package reusable logic and make scripts safe to run repeatedly. Nice. Let's continue. Question 2. What is the difference between a Python list, tuple, set, and dictionary? Here's a strong way to approach it. A list is ordered and mutable. A tuple is ordered and immutable. A set stores unique unordered values, and a dictionary stores key value pairs. Lists are useful for sequences, tuples for fixed records, sets for membership checks, and dictionaries for structured mappings. Choosing the right type improves readability and performance. Great. Moving on. Question 3. Explain Python virtual environments. Here's a strong way to approach it. A virtual environment isolates Python dependencies for a project so packages do not conflict with system Python or other projects. It helps make builds reproducible and easier to debug. In CI or CD, virtual environments or container images should be used consistently. Alright, next question. Question 4. Scenario. A Kubernetes deployment keeps failing only during peak traffic. What would you investigate? Here's a strong way to approach it. Check resource saturation, auto-scaling behavior, startup time, readiness probes, connection pools, database limits, queue depth, rate limits, and downstream latency. Compare peak and normal metrics to identify the bottleneck. Fixes may include prescaling, tuning HPA, improving caching, increasing dependency capacity, or adding back pressure. Let's keep going. Question 5. How do you design a zero downtime Kubernetes deployment? Here's a strong way to approach it. Use rolling updates, readiness probes, graceful shutdown, pre-stop hooks, proper termination grace period, and backward compatible application changes. Ensure database migrations are expand and contract instead of breaking old versions. Add canary or blue-green deployment for high-risk changes. On to the next one. Question 6. Scenario. A database migration breaks the new application version. How should deployment be designed? Here's a strong way to approach it. Use backward compatible migrations. Deploy schema changes before application code, and avoid destructive changes until all old versions are gone. A safe pattern is expand, migrate data, switch application, then contract. Rollback planning should include both application rollback and data compatibility. Good. Here's another one. Question 7. What are Kubernetes pod disruption budgets? Here's a strong way to approach it. Pod disruption budgets define how many replicas of an application must remain available during voluntary disruptions such as node upgrades or drains. They protect availability but can also block maintenance if configured too strictly. They should match the application's real redundancy and slow requirements. Nice. Let's continue. Question 8. Scenario. Node upgrades are stuck in GKE. What could be causing it? Here's a strong way to approach it. Strict pod disruption budgets, pods without enough replicas, local storage, unmanaged workloads, or scheduling constraints can block node drains. Check events, disruption budgets, and pods remaining on the node. Fix by adjusting budgets, scaling replicas, or safely relaxing constraints during the maintenance window. Great. Moving on. Question 9. What is a Kubernetes network policy? Here's a strong way to approach it. A network policy controls allowed ingress and egress traffic for selected pods. It is used for segmentation, least privilege, and reducing lateral movement. Policies require a network plugin that enforces them, and default deny policies are common in secure clusters. Alright, next question. Question 10. Scenario. A service cannot connect to another namespace after enabling network policy. What do you check? Here's a strong way to approach it. Check whether default deny policy is active and whether ingress and egress rules both allow the traffic. Verify namespace selectors, pod selectors, ports, protocols, and DNS access. Also confirm the CNI plugin supports network policy enforcement. Let's keep going. Question 11. How does Kubernetes DNS work? Here's a strong way to approach it. Kubernetes DNS resolves service names to cluster IPs and pod DNS records where configured. A pod can usually reach a service using short names in the same namespace or fully qualified names like service namespace SVC cluster local. DNS issues can come from core DNS failures, network policy, node DNS configuration, or overloaded DNS pods. On to the next one. Question 12. What are common GCP networking components? Here's a strong way to approach it. Important GCP networking components include VPCs, subnets, firewall rules, routes, Cloud NAT, Cloud Router, VPN, Interconnect, Private Service Connect, internal load balancers, and external load balancers. In GKE, alias IP ranges and secondary ranges are also important. Good design separates environments, limits exposure, and plans IP ranges carefully. Good. Here's another one. Question 13. Scenario. GKE pods cannot reach the internet from private nodes. What do you check? Here's a strong way to approach it. Check Cloud NAT configuration, routes, subnet association, firewall rules, DNS, and whether private Google access is needed for Google APIs. Private nodes do not have public IPs, so outbound internet usually requires Cloud NAT. Also verify organization policies are not blocking egress. Nice. Let's continue. Question 14. What is VPC service controls? Here's a strong way to approach it. VPC service controls creates security parameters around supported Google Cloud services to reduce data exfiltration risk. It can restrict access based on project, network, identity, and context. It is powerful but can break workloads if service access patterns are not mapped carefully. Great. Moving on. Question 15. Scenario. A data pipeline fails after enabling VPC service controls. How would you debug? Here's a strong way to approach it. Review audit logs for perimeter violations and identify source project, identity, target service, and API method. Check whether required projects and services are inside the same perimeter or need access levels or bridges. Fix the perimeter rules carefully and retest with the exact service account used by the pipeline. Alright, next question. Question 16. How do you use cloud logging and cloud monitoring effectively? Here's a strong way to approach it. Collect structured logs, define useful metrics, create alert policies based on user impact, and build dashboards around slows. Avoid alerting on every warning, alert on symptoms that require action. Use labels such as service, environment, namespace, and version to make debugging faster. Let's keep going. Question 17. Scenario. Your alert fires but users are not affected. What should you do? Here's a strong way to approach it. Treat it as an alert quality issue and review whether the alert is based on symptoms or internal noise. Tune thresholds, add duration windows, route low priority signals to tickets, and connect alerts to runbooks. The goal is fewer, better alerts that improve response without causing fatigue. On to the next one. Question 18. What is slow? Here's a strong way to approach it. slow is a target level of reliability for a service, such as 99.9% successful requests over 30 days. It is based on service level indicators like availability, latency, or correctness. Slows help teams balance reliability work against feature delivery using error budgets. Good. Here's another one. Question 19. Scenario. Error budget is almost exhausted. What actions would you recommend? Here's a strong way to approach it. Slow or freeze risky releases. Focus engineering time on reliability fixes. Review recent incidents, and improve observability and rollback speed. Prioritize work based on user impact and the biggest sources of error budget burn. Communicate clearly with product and leadership about the trade-off between speed and reliability. Nice. Let's continue. Question 20. How do you secure a CI or CD pipeline? Here's a strong way to approach it. Use least privilege credentials, short-lived tokens, protected branches, required reviews, signed artifacts, dependency scanning, secret scanning, and deployment approvals for sensitive environments. Build images from trusted bases and store artifacts in controlled registries. Audit every production deployment and make rollback easy. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.